Welcome back. Before we demonstrate how we can improve performance, we first need to show how we might run into performance problems. Let's start by building out a very simple example to show the effects of blocking the event loop in a Node server. I'm in my performance example folder here, which is going to be an Express server. So in our terminal, let's create a package for our server with our npm init-y command. And now that we have our package.json, we'll npm install Express. Now our server code is going to live in server.js, which is going to create an Express application. So const express equals require express. We'll initialize our Express application, const app equals express, and we're going to have two routes. One, an app.get route at our main root endpoint here, which takes in the request and the response, and is just going to respond with, so using our res.send function, we're just going to say performance example. That's the name of our server. And our second route is also going to be a get. This time, we're going to call it the timer. And we'll see why in just a second. So it also takes in a request and response. Now, it's going to delay the response for a few seconds before responding back to the client. So we'll delay the response, and then we're going to send, after our timer has completed, we'll try to wake the user up by saying, ding, ding, ding. How are we going to delay the response? For the sake of our example, we're going to take this naive approach by writing a function that we'll call delay, and it accepts an argument called duration, which is the amount of milliseconds the function is going to wait. Now, here's the catch. The way we're going to delay is by basically spinning in place, doing nothing in JavaScript, with a while loop, which checks basically the start time of when we call our function. So start time will equal to date.now, which is the current time represented in milliseconds. And our while condition is going to check date.now as well, minus the start time when the function was called, checking that the difference in those two times has been less than the duration of our delay. And inside of our while loop, well, we're not going to do anything special. We're just going to constantly check whether the current time minus the start time has been less than the duration of our delay. Our JavaScript will loop over this condition until we've been waiting longer than the duration. And while JavaScript is checking this condition and looping over it, well, our event loop will be blocked. JavaScript code, like our delay function, is processed on the event loop. It's not a file or network operation, so it's not going to be sent to the thread pool or passed off to the operating system, like many of our built-in Node functions. Instead, while we're in our loop, the event loop is completely blocked. This means that if we call our delay function in our timer endpoint, passing in some amount of time, let's say 9,000 milliseconds or 9 seconds, our server can't do anything else while our delay function is executing. It can't process other requests or parse any files or make queries to our database. No other JavaScript code will be processed. Let's find out what effect this has on our server. So we still need to call app.listen, and we'll listen on port 3000. Any port works here as long as it's not conflicting with another server that's running on our computer. And now I'm going to run npm start. When that's started, let's go to our browser and try to make some requests against our server. Let's open up our JavaScript console here, going to our network tab, and try to make some requests to our server at localhost on port 3000. Let's go to our root endpoint. Looks like that's working. The request took about 189 milliseconds. I have a lot of different applications running on my machine right now. Normally, this request would take less than 20 milliseconds. One of the challenges in this section, and with measuring performance in the real world, is that the exact behavior depends on the conditions of your measurement. The applications you're running, your CPU speed, your operating system, even your version of Node can all play a role. Because of that, I encourage you to follow along with this section and play around with how the server responds on your machine. It's likely you will see at least some differences compared to what I have here. What I can guarantee is that the same concepts we're learning apply regardless of your machine. But let's see here. The first request often takes a little bit longer. If I make it again by refreshing, we're getting about 145 milliseconds. Now in the timer route, we can go to /timer and wait around until our server responds after just over 9 seconds. Our delay function is simulating some work that takes 9 seconds to complete, just like we expect. Now, here's the catch. If I go to another tab and I open up my network tab as well, network, and let's say I go to the /timer endpoint here, and then really quickly switch to the other tab and try to load the same endpoint. How long will it take for my response to come back from the server? Let's see. In the first tab, we'll go to the timer endpoint and quickly refresh the other tab. We can see the response is pending in the second tab. It's come back after 9 seconds in the first tab, but in the second tab, it's still pending. It's only after 19 seconds that our response came back. That's more than twice as long as it should have taken. This is crazy. Because the first request blocked the event loop, the second request wasn't able to start. The Express server wasn't able to respond to it until the first response completed and that timer expired. Our CPU and the event loop are really, really busy here, spinning on this condition as fast as our CPU can go. Our event loop won't continue until our delay function returns, which means our server won't be able to respond to any requests. If we go back to the browser, and in one tab I go to the timer endpoint, and in the second I go to the root, even though the root should only take about 100 milliseconds to complete, it actually ended up taking 6.5 seconds, because even after I switched tabs and pressed refresh, which took me about 2.5 seconds, the timer endpoint was still executing. Our blocking code is slowing down the entire server. There needs to be a better way of handling this so that our server doesn't grind to a complete halt. Let's keep going and investigate some different approaches we can take to improve this situation. But first, I know this example is a little bit contrived. It's not every day that we write while loops that don't do anything for a certain amount of time. So let's explore some real-life examples that behave similarly. I'll see you in the next video.